In this video, we're going to work through the practice questions for asymptotes. The first question asks, what is the vertical asymptote of the function f of x equals 1 over x squared minus 1? And when we're looking for vertical asymptotes, we want to think about the denominator. And the vertical asymptote occurs when the denominator is set equal to 0. This is where we can't have 0 in the denominator. And remember, an asymptote is going to be that line that the graph approaches but does not usually cross. And for most cases on the ACT, it's not going to cross. So we're going to solve for x, and we'll bring this 1 over. We take the square root of both sides, and we get that x is equal to plus and minus 1. Don't forget the plus and minus when we take the square root. And so that gives us answer choice E, x is equal to negative 1, and x is equal to 1. So on our graph, if this was the point negative 1, I already had that drawn out, so I used it. And this would be our positive 1. These would be our two asymptotes that the graph here would not cross. Question 2, what is the horizontal? Now we're looking at horizontal asymptote. If there is one for the function f of x equals x plus 3 divided by x squared plus 5. So when we're looking at the horizontal asymptote, what we're looking at is the variable that has the largest exponent. And in this case, we only have this one, x squared. It is in the denominator, and by definition, if this is the case where the largest exponent is only in the denominator, we're going to automatically have a horizontal asymptote of y equals 0. And that gives us answer choice H. This is just a by definition kind of thing that you want to keep in mind. There are other rules for horizontal asymptotes, and we'll talk about some of those in the next examples. Number 3 says, what type of asymptotes does the function f of x equal to 3x squared plus 1 divided by 4x squared minus 1 have? So you've already in the first two questions had to find a vertical asymptote in number 1, a horizontal asymptote in number 2, and then we have this type of question we might see where they just ask what type of asymptotes exist. And there's some features of functions that we can look for to know that. The first one we always want to look at first, or I do, is for vertical asymptotes, and that's when the denominators equal to 0. And in this case, we would have a denominator equal to 0 case here. We have x squared equals to the 1/4. We don't even have to solve all this, but we can verify to ourselves that there would be a vertical asymptote when we take the square root of both sides. X is going to be plus or minus 1/2. So we do have a vertical asymptote. So answer A is still in the running. B is out because it only says horizontal. C only says oblique. D is a possibility and E is a possibility. So we've got to see, do we have a horizontal? That would be the next one I would check. And like we talked about in the number 2 example, to find the horizontal asymptote, we're going to look for the terms with the highest exponent. In this case, we have that in the numerator and the denominator. So when we have that case, we look at the coefficients of each of these. We have the 3 and the 4, and we can just say that the horizontal asymptote is equal to y equals 3/4. So in this case, we do have a horizontal asymptote. We have a vertical, and the only answer that's going to work for that is answer choice D. So moving on to number 4, where do the vertical and oblique asymptotes intersect for the function f of x equal to x squared minus 3x divided by 2x minus 2? So we're going to have to look at both a vertical and oblique and find their point of intersection. So let's start with the vertical. To me, that's always the easiest. I'm looking at the denominator, and I'm going to set it equal to 0. And when I have 2x equal to 2, x is going to be equal to 1. That gives us the vertical asymptote. And if you're thinking about this on our graph, here's our asymptote of x equal 1. So that's a vertical line. So our asymptote is going to cross somewhere on this value of x equal to 1. So we already know one part of this point of intersection, and that is that the x value is 1. We don't know the y value yet. So we can look at our answer choices. We can eliminate F and G because they have different x values. When we're looking at our oblique asymptote, we have to usually do some division. There's an oblique asymptote when you look at the variable with the largest exponent, which in this case is the x squared, and it's only in the numerator. That's going to be a case when we have an oblique asymptote because we can do division. In this case, I'm going to do long division because our oblique asymptote is what we think of that whole part of when we do division, not the remainder. So when I divide 2x minus 2 into x squared minus 3x, I look at this 2x and I say, how many times will it go into x squared? Well, because we have this 2 out in front, it's a little tricky. We're going to need to put a 1/2 x so that when we want it to cancel out when we multiply through here and put this underneath. So 1/2 x times 2x, that gives us that x squared. 1/2 x times a minus 2 is going to give us minus x. And then when we subtract, we're going to go through and flip all the signs. X squares canceled out, and now we have negative 3x plus x gives us a negative 2x. Now we can do our division again. 2x minus 2 into the negative 2x, that's going to go negative 1. Let's do our multiplying. Negative 1 times 2x is a negative 2x. Negative 1 times negative 2 gives us a plus 2. Draw our lines. We're going to subtract, so we flip all the signs. That now becomes a negative. That cancels out, and we have negative 2. That's our remainder. But what we're interested in is this whole value part, which gives us an oblique asymptote of y equals 1/2 x minus 1. We get that from the long division here. At times you can use synthetic division as well, but this problem makes it a little bit more difficult because we're working with this 2x. You could still do it factoring out the 2, but I chose to do long division here. So now, how does that help us? Well, we need a y value. And here is where we're going to find it. So we're going to plug in an x value of 1 because that's where we know it intersects at some value of x equal to 1. Simplify here, we get 1/2 minus 1, which gives us a negative 1/2. That's going to be our y value, negative 1/2. So that's the point 1, negative 1/2, and that is answer choice J.